In this video, we want to solve for the value of y. Now, to do this, looking at this problem, we can write this given equation as 4 to the power of y, and in parentheses, here we have 1 plus 1 divided by 2 to the power of y, which is equals to 20. And from here, so here we have 4 to the power of y multiplied by 2 divided by 2 to the power of y, which is equals to 20. Now, from here, it makes it a little bit easier. And what we got to do here is to divide, or let's say multiply both sides by 1 over 2. 1 over 2. So if you do that, you can see that this 2 is going to cancel out this, and this 2 is going to divide this 20, in which we're going to get 10. So we're going to get 10 here. So here we have 4 to the power of y divided by 2 to the power of y, which is equals to 10. And from here, we can further simplify by having 4 divided by 2, everything to the power of y, which is equals to 10. So from this, we can have 4 divided by 2 is the same thing as 2 to the power of y, which is equals to 10. Now, solving from here, we can apply logarithm to both sides. So here I'm going to have my log 2 to the power of y equals to log 10. And moving this y backward, from here, I can have my y log 2 equals to log 10. Now, here I have my y log 2 equals to log 10, can be written as 2 times 5. And so here we have y log 2 equals to, from the rule of logarithm, if we have log a times b, this is the same thing as saying log a plus log b. This is the rule of logarithm. So I will be applying this rule of logarithm to solve this problem. So here, this is going to be log 2 plus log 5. Don't forget they have the same base, which we assume to be base 10. So here, dividing both sides by the coefficient of y, which is log 2. Log 2. So here on the left side, I'm going to have y. Also, the rule of algebra that says a plus b over c. This is the same thing as saying a over c plus b over c. Both of them can share the same denominator. So here, I'm going to have log 2 divided by log 2 plus log 5 divided by log 2. So here my y is going to be log 2 divided by log 2 is 1 plus log 5 divided by log 2. Also, mathematically, if you have log a over log b, and both of them have the same base, so it is mathematically correct for you to say this is going to be log a base b. So here, my y is going to be 1 plus log 5 base 2. Now, this is what I've gotten to be the value of my y. But what if this value is not right? What if this value is not right? There's a need for us to confirm if this value is correct. So here, I have y to be equals to 1 plus log 5 base 2. Let me check. I need to check. Recall that the problem we have initially is 4 to the power of y plus 4 to the power of y over 2 to the power of y equals to 20. So we want to confirm if this is actually true. This is what we want to do. Now I'm going to plug in this value of y into this given problem and to see if it is actually going to be equals to 20. Now, to do that, we have 4 to the power of y. Here, y is going to be 1 plus log 5 base 2 plus 4 to the power of 1 plus log 5 base 2. This can be divided by 2 to the power of log 1 plus log 5 base 2. So we want to establish if this is actually equals to 20. Now, from here, using the law of indices, when you have a to the power of b plus c, mathematically it is safe to say this is a to the power of b times a to the power of c. Now, I'll be using the same logic to solve this. This is safe to say 4 to the power of 1 times 4 to the power of log 5 base 2 plus 4 to the power of 1 times 4 to the power of log 5 base 2 divided by 2 times 2 to the power of log 5 base 2. Now, solving this further, from here, we can verify that 4 to the power of log 5 base 2 is common to both sides. So factor it out. And in parentheses, I'm going to be left with 4 plus 4 divided by 2 times 2 to the power of log 5 base 2. Now, this is what we've got. Now, here we have this 4 can be written as 2 to the power of 2 log 5 base 2. And in my parentheses, 4 plus 4 is going to be equals to 8. So this will be multiplied by 8. Dividing this by 2 times 2 to the power of log 5 base 2. Here, 2 here 1, and 2 here we have 4. So here, this can be written as, also the rule of log says when you have a log b, this is the same thing as saying log b to the power of a. You can move this to the top. So here we have 2 to the power of log 5 squared base 2 multiplied by 4 divided by 2 log 5 base 2. Now, there's another rules of logarithm, which is log, when you have b to the power of log a base b, if the base and this, the exponent, they are the same, your answer is going to be a. So I'm going to use this rule here too. You can see that the base of the log here is equal to the base of the exponent, which is 2. So my answer is going to be 5 squared multiplied by 4 divided by 2 divided by 5. because 2 are the same, so your answer is going to be 5 here. So here we have 5 squared, which is 25 times 4 over 5. Here we can verify here that 5 here 1, 5 here 5. So 5 times 4 is 20, which shows the left hand side is actually equals to the right hand side. So this is the end of my proof. If you enjoyed this video, kindly like this video, please. And if you have an alternative way of doing this, you can share with me in the comment section. I'll be willing to see your feedback. Thank you.